Hello, this is video lesson 1-3 and this begins on page 11. Now on September 1st, 2016, I had you do this do now, and basically this lesson is on absolute value equations and inequalities. Just a really quick thing about absolute value. The absolute value of a number, it basically makes anything inside the absolute value positive. So an absolute value is always going to give you a positive answer. And if you have a positive number inside the absolute value, well, nothing changes. It just stays positive. Okay, question number 1. Solve and graph the absolute value equation. Well, looking at this, what can x be so that my answer is 3? Well, take a look at this. Here I have an answer of 3, and it turns out that x can equal -3. Is there any other number I can plug in so that I can also get 3? Well, I can also plug in the absolute value of 3, and that also gives me 3. So x equals -3 or x equals 3. So we just basically plug that on the number line, and these are basically dots on the number line, points on the number line. Okay, question number 2. How many solutions does an absolute value equation have? Taking a look at this equation so far, an absolute value equation is going to have at most 2 solutions. And we're going to see examples of where we have just 1 solution and also 0 solutions. Okay, the next thing I had for you is to solve the absolute value of x less than 3. Now, just a really quick side note, the way you know this would be less than 3, less than, is basically it looks like an L. So if it looks like an L, then you know that's less than. And if it is the other way, well, that is greater than. Okay, so solve the absolute value of x less than 3. Well, first of all, looking back at the absolute value of x is equal to 3, we are still going to have these 2 points on our number line. So let's go ahead and put them on there. Now, what does it mean for x to be less than 3? Well, what numbers are less than 3? What numbers are going to be less than 3? Well, 2 is less than 3, so you can say that 2 is going to be less than 3. You can also say that 1 is less than 3, and 0 is less than 3. Now, think about this. Are there any negative numbers that we can plug into the absolute value that are going to be less than 3? Well, if we put -1 into the absolute value, that gives me 1, and 1 is less than 3, so we can put that in. If we put in the absolute value of -2, that equals 2, and that is also less than 3, so 2 is part of my solution. What about -4? If I plug in -4 into my absolute value, that's going to give me 4. Now 4 is not less than 3. So really, my solutions are going to be in between -3 and 3. So we have an interval that is shaded in between the 2 solutions of -3 and 3. Okay, so we have our solutions of -3 and 3. And we're talking about the variable x. Now, what inequality is going to go in between both of these in order to write this in inequality form? Well, just taking a look at one side, just taking a look at this side, are my x values in my interval greater than 3 or less than 3? Well, you can see here's 3 right here. The shaded area is, as we can see, they are all less than 3, so we're going to use this symbol right here. Alright, looking at -3 now, are my values in my interval less than or greater than -3? Well, they're larger than -3, so this means that x is going to be larger than -3. So notice when we go ahead and write the interval notation, inequality notation, basically the inequalities are going to be the same in this case. Okay, so whenever we have an inequality, the absolute value of an inequality, we need to have the inequality written and we need to have the interval graphed. Now let's go ahead and take a look at the absolute value of x is greater than 3. Again, we still have our two solutions, -3 and 3, but this time what can I plug in for x so that this statement is true? Well, looking at it just as x larger than 3, what numbers are larger than 3? Well, basically 4. 4 is going to be larger than 3. 5 is also larger than 3. And actually all these numbers on the right of 3 are going to be shaded. These are part of the solution. Now, are there any negative numbers, the absolute value of negative numbers, that are going to be larger than 3? Well, if I take the absolute value of -4, that gives me 4, which is larger than 3. And the absolute value of -5 is also larger than 3. And it turns out that if I just go to the left of -3, every number is going to be shaded. Now we want to write our solution in inequality form. So we have -3 and we have 3. X is in the middle. So whenever the shaded area is on the outside, basically the inequality is going to be greater than. So -3 is greater than x, and then x is greater than 3. Okay, so basically whenever the inequality is less than whatever number this is, it's going to be shaded on the inside, and you're going to use the less than symbol. When the absolute value of x is greater than a number, you're going to be shading on the outside of those solutions, and the inequality you're going to use is going to be greater than. Alright. Number 4, does the absolute value of x equals -3 have any solutions? Let's take a look here. Remember when I introduced the inequalities, I basically said that the inequality takes any number and the answer is always positive. So -3 becomes +3, -2 becomes +2, and if you already have a positive number, it basically stays the same. So are there any solutions when we have an absolute value and the solution is negative? Is that even possible? Nope. The absolute value always gives you a positive answer. So absolute value of x equals -3 does not have any solutions, so there are no solutions. Alright, so page 11. The learning targets are to write, solve, and graph the absolute value equations. This is going to be broken apart into 2 halves, so this video is going to concentrate on writing, solving, and graphing absolute value equations. Okay, really quick, this was part of the do now. Basically, our two solutions were 3 and negative 3. X equals 3 or x equals negative 3. So commonly, an absolute value equation has two solutions, but the important thing about this is that an absolute value, when you write it into two equations, one solution is going to be positive. This is x equals positive 3, and the other solution is going to be negative. So very important concept here. One solution is positive and the other is negative. Okay. Alright. Let's take a look at this one. The absolute value of x minus 2 is equal to 3. So following that basic concept, I'm going to take this absolute value and write two equations. And this is what I mean. X minus 2 equals 3. Notice I have my positive 3 here, and then I'm going to write x minus 2 equals negative 3, and here is my negative 3 right there. So following the basic concept of what we have here, basically we take this absolute value equation and write two equations where one solution is positive and the other one is negative. Okay, so this is taking that basic concept. So now that we have two equations, we basically solve each one for x, and here we have to add 2 to both sides. So x equals 3 plus 2, which is 5, or here again we add 2, and we have x equals negative 3 plus 2, which is negative 1. Those are my two solutions, and we go ahead and plot them on the number line. There we go. Those are our two solutions. Alright, let's take a look at another one. Here we have the absolute value of x plus 2 equals 3, and again we want to take this absolute value and write two equations. So the first equation is going to be x plus 2 equals positive 3, or x plus 2 equals negative 3. Remember, you're always going to have a positive and you're always going to have a negative number. So just to be very clear, whatever's inside the absolute value stays the same. Nothing changes. The sign does not change. Nothing in the sign changes. Whatever is on the other side of the absolute value expression, this is where the sign changes. So this is positive 3 and this is negative 3. And you're always going to have two equations. Okay, let's solve each of them for x. Here we have to subtract 2 on both sides. So we have x equals 3 minus 2, which is 1. Or we subtract 2 here again, and we have x equals negative 3 minus 2, which is negative 5. Here are our solutions, and so x equals 1 and x equals negative 5. Okay, so we went from learning the basic idea of an absolute value equation. It has two solutions where one is positive and the other one is negative. Now we want to go ahead and take a look at this type of problem where we're starting to build up, going up a level, and taking a look at solving this type of absolute value equations. Okay. So taking a look at this, you may be tempted to do this. Well, I have my 2 absolute value of x minus 1 minus 5 equals 1. Well, there's my first equation. Or I have 2 absolute value x minus 1 minus 5 equals negative 1. Well, I wrote my 2 solutions. Now I can go ahead and solve for x. This is not correct. And let me go ahead and give you the very first step to solving absolute value equations. The first step is to isolate the absolute value expression. So my absolute value expression is basically everything in between these vertical lines. I want to get this absolute value expression to by itself on one side. So notice here it's by itself on one side of the equal sign. Again, same thing here and same thing here. Once it's isolated on one side of the equal sign, I can basically write the 2 equations. So basically I jump to writing the 2 equations there and also there. But not the case here. I need to isolate the absolute value expression. So basically the method that I like to use is reverse Pemdas, where addition and subtraction are on one level, multiplication and division are on a second level, exponents, and then parentheses. Alright, so reverse Pemdas, the first thing I want to look at is if I have any addition or subtraction. And also parentheses, we're going to include absolute value. So parentheses and absolute value are going to be on the same level, so those are going to be last. Okay, so first of all, I'm looking for addition and subtraction. Well, I'm not going to look at this negative 1, minus 1 inside the absolute value because that is last. So I do have minus 5. So let me write the equation. So I do have minus 5. That is in my first level. That's the first thing I look at. And the inverse or the opposite of subtracting 5 is to add 5. Whatever I do to one side, I must do to the other. Minus 5 plus 5 becomes 0. 5 plus 1 becomes 6. So now I have the absolute value of 2. 2 times the absolute value of x minus 1 equals 6. Okay, no more addition or subtraction. My next level is to look for multiplication or division. Here I am multiplying the absolute value by 2, so I must do the inverse or opposite of multiplying by 2, which is to divide by 2. Whatever I do to one side, I must do to the other. 2 over 2 basically becomes 1, so I have the absolute value of x minus 1 is equal to 6 divided by 2, which is 3. Now take a look at this. Did I complete step 1? Did I isolate the absolute value expression? Is it by itself on one side? Yes. That leads me to step 2. Step 2, write the absolute value into 2 equations. So that's basically what we did here. We wrote 2 equations, and also that's what we did here into 2 equations. Remember, in those 2 equations, one is going to be positive and the other one is going to be negative. Specifically, it's on this side. This is where the sign changes, not inside the absolute value. So let's go ahead and write those 2 equations. So I have x minus 1 equals positive 3, or x minus 1 equals negative 3. Okay, so we're done with step 2. Now all we have to do is simply solve each one for x. So we have to add 1 to both sides. So x equals 3 plus 1, which is 4. Or here we have to add 1 to both sides again. And here we have x equals negative 3 plus 1, which is negative 2. There are our 2 solutions. Let's go ahead and put those points on their number line, and there we go. Okay, so using those ideas, you're using the idea of the first step, isolate the absolute value expression. And then once you isolate it, you want to write the absolute value into two equations. And then you can go ahead and solve for it. So that's basically the idea here for A, B, C, and D. Now, let me give you a hint. Both of these are going to have two solutions. That's basically what we've been commonly seeing. Let me give you a hint for this one. C and D, you want to make sure they are not going to have two solutions. And by the way, looking at our warm-up, we said that an absolute value equation has at most two solutions. So either C and D have 1 or 0 solutions. So just keep that in mind. And I've showed you an example of how an absolute value equation can have 0 solutions. That is in your do now as well, specifically this last question right here. Okay, now that we have looked at this, and let's just take a look at number 1. How many solutions are possible for an absolute value equation having the form absolute value of ax plus b equals c, where a, b, and c are real numbers? Don't let this notation confuse you. This is basically saying that if a was any number such as 3, x, and then b was any number such as 5, equals c, any random number such as 4. How many solutions are possible? That's basically what it's asking. Okay, now I want to point out something very important. If we take a look at our very first absolute value equation that we looked at, notice that at 0, zero is at the center, and notice that the solutions at either side are 3 units away. Hence, this is why we have 3 right there. This number lets us know that the answer varies 3 units away from 0. Now, let's take a look at this second equation. Where is the midpoint, basically, of the two solutions? Well, looking at it, you can say that it's 2. So 2 is the target. So let's call 2 the target. Where in this equation do we see a 2? Well, here we have a -2. Could this -2 possibly hint at us that that is where the midpoint or the target is at? And this 3 right here tells us that from the target, the solutions are both 3 units away. So 1, 2, 3, and 1, 2, 3. But since this is -2, that means that whatever is here is basically the opposite. So if we have -2, then +2 is where the target is at. So this is an interesting idea. So maybe the target is basically the opposite of what's inside the absolute value. And let's say that 3 is what varies. So notice that from the target, the solutions varies 3 units to the right and also varies 3 units to the left. Is this going to work for other ones? Well, let's take a look at this one. If we take a look at the target, here we have +2. Well, again, the target is going to be the opposite of positive 2, which in this case is negative 2. Is that in fact in between those two solutions? Yes, it is the midpoint of those two solutions. And notice that 3 is what varies on each side. So from the target, we see that it varies 3. The solutions vary 3 from negative 2 on both sides. This is an interesting idea. What about the very last example that we did? Looking at this one, we can see that when we isolated the absolute value equation, notice this only works when you isolate, so we can't go and say that this is the target and this is what varies. We have to make sure that it's isolated. And so here is our equation. So here we see that we have negative 1, so our target is going to be positive 1. So our target is right here, and what varies is going to be 3. And we can see that by the number line, this turns out to be true in every single case. Okay, so let's summarize what we have here. If we wanted to go ahead and graph A and B just by observing what we just saw, let's take a look at A. It's already isolated, so our target, we have the number negative 2, so basically the target is the opposite, which is going to be 2. So our target is 2, and our solutions are going to vary 3 units away from either direction. So our solutions are going to be 1, 2, 3 to the right, and it's also going to vary 1, 2, 3 to the left. So without even making much calculations, we basically found both of our solutions, x equals negative 1 and x equals 5. Let's take a look at B. Now we have to do some work with B because we have to isolate the absolute value, so this is just a really simple fix. We can add 4 to both sides, and what we get is the absolute value of x plus 1 equals negative 2 plus 4, which is 2. Okay, now we can go ahead and look at our target. Here we have positive 1, so our target is negative 1, and what is going to vary is 2 units in either direction. So here 1, 2, 1, 2. So our solutions are x equals negative 3 or x equals 1. So I leave it up to you to verify that these are in fact correct, but I will go ahead and tell you that they are. But I recommend that you check on your own too. Okay, so this technique is very useful to help you find the solutions in a faster way, but it is also going to help us solve some word problems that have absolute value equations. So let's go ahead and take a look at an example. Here we go. Well, let's take a look at example B. And let's take a look at it. The temperature of the wave pool at Sapphire Island can vary up to 4.5 degrees Fahrenheit from the target temperature of 82 degrees Fahrenheit. Write and solve an absolute value equation to find the temperature extremes of the wave pool. The temperature extremes are the least and greatest possible temperatures. So notice here are the keywords: vary up to 4.5 degrees Fahrenheit and a target, in this case temperature of 82 degrees Fahrenheit. So remember, the setup was that whatever's next to the x is going to be the target, and whatever's on the other side of the equal sign is what varies. So let's go ahead and draw our absolute value equation. What goes here is going to be x. Our target temperature of 82 degrees, remember the target whatever goes in here is basically the opposite. So the opposite of positive 82 is negative 82. Then we have our equal sign, and what varies is going to be here, which is 4.5 degrees. So from the word problem, we were able to figure out our absolute value equation. So we wrote the absolute value equation. Now we have to solve it. Again, we can go ahead and solve this very easily. Remember that our target is at positive 82, basically the opposite of this. So we can go ahead and write 82 at the center and basically go 4.5 units away in either direction to get our solutions. So 82, 4.5 units to the right, 83, 84, 85, 86, 86.5. And going to the other direction, 4 units to the left, 4.5 units to the left, we have 81, 80, 79, 78, and if we want to go 0.5 less, it's basically 77.5. So this requires a little bit more thinking because we have to deal with decimals, but here are our two solutions. So basically x equals 77.5 or x equals 86.5. And of course, I also recommend that you solve this. You can break this down into two equations. Let me just show you really quick. We can write this as x minus 82 equals positive 4.5. Remember, one of them is going to be positive and the other one, x minus 82, equals negative 4.5. Basically add 82 for each equation, and here we do in fact get x equals 86.5, and the other equation, when we add 82, we get x equals 77.5. Okay. So now I leave it up to you. Well, there's one more thing. One more thing in example B is that how to interpret the solutions. It's not just in mathematics, it is not just enough to find the solutions. We have to know what these solutions mean, and so that is very important. What are we talking about here? 86.5 and 77.5. What are those numbers? Well, they are degrees in Fahrenheit. So we have 86.5 degrees Fahrenheit and we have 77.5 degrees Fahrenheit. But they're degrees. What's so special about these numbers? Well, they are the temperature extremes. One of them is the least possible temperature, and one of them is the greatest possible temperature inside the wave pool at Sapphire Island. So basically, the way you want to write this out is that 77.5 degrees Fahrenheit is the least possible temperature and 86.5 degrees Fahrenheit is the greatest possible temperature at the wave pool. Okay, so there's the interpretation. This is something that we can relate to the real world. This is just a solution from a math equation. So it's important to go from the solution of a math equation into something from the real world that we can tie it to. So that is always going to be stressed in this class. Alright, we'll continue with the second half in the next video.